I'm going to quickly go through this Skycoaster problem. So the problem, as given by the last activity, is you have some people who are suspended from these two cables that go up to these two towers. And the question is, what is the tension in this cable? And the question asked you two different ways. One was just using symbols, and the other with some numbers in here. And for most students, doing it with symbols, they find it harder. That doing all the arithmetic confuses them more. But it's really good practice to do it both ways. Typically on exams, we will mostly give you questions that involve numbers. But it really tests your understanding to be able to do it both ways, and I think it's great to develop those skills. All right, so the first step of a problem like this is we're going to annotate this picture to draw the forces. And there are three forces acting here. There's weight. There's the tension in this rope. And the tension in that rope. Okay. The next step is to draw a free body diagram. And in some sense, the free body diagram doesn't look much different than the sketch. But I'll nonetheless do that. Okay. A couple other things we can do is we can add some axes. And we can label our angles on here too. The next step in these problems, so this is a statics problem, nothing is moving. And so the principle we're going to be using is that the net force should vanish. So we need to calculate the net force. And the net force is a vector, so we have to separately calculate the x and y component of the net force. So the x component, x, okay, that is the projection of this vector onto this line, and the projection of that vector onto this line. And we know it has to be some trigonometric function. Is it cosine? Is it sine? Right? And in some sense, you just have to memorize this. You can have various mnemonics. So the mnemonic I always use is that cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. And we are looking at the projection down here. And so that is adjacent to this angle. So it should be cosine. Okay. So we're going to have a T1 cos theta 1. We're going to have a T2 cos theta 2. The other thing we have to keep track of is the signs. So if I look at this vector here, its x component is in the positive x direction. So this should come with a plus. On the other hand, this vector, its x component is in the negative x direction. So it should come with a minus. Okay. The other equation we have is for the y component of the force. So this is going to be 0 because of the statics problem. And again, we just need to use our trigonometry to project these forces into the y direction. And in some sense, we've already done the work of figuring out the other one is cosine, so this one must be sine. So we have a T1 sine theta 1. We have a T2 sine theta 2. And we have a W. And then we just have to go in and put the signs. Okay. So the projection of both of these in the y direction is up. They're both pulling up. And this one is pulling down. So I want a minus, plus, plus. Now, if we are supposed to do this problem symbolically, what we'll first do is we'll solve this equation for T1 in terms of T2. And so I bring the T1 cos theta over to one side. Okay, and then I divide by cos theta 2. Right? And that should be a pretty simple manipulation for you. If you're dealing with numbers, we could directly substitute numbers in. And we could start just with minus T1 cos 60 degrees plus T2 cos 15 degrees, 0. And I punch this in my calculator. This cos 60 degrees, that's 1/2. Cos 15 degrees, right? That's something like 0.966. You have to be careful to have your calculator in degrees. Okay. And then I can, again, pull one of these over to the other side. So I get 0.966 T2 equals 0.5 T1. And then I divide by cos theta 2. So T2 equals 0.5 over 0.966 T1. And plugging in that my calculator, I get 0.52. Okay, which clearly you could get the same result by just plugging in the numbers here. Okay, and as you see, the amount of work of doing this with symbols versus numbers is the same. But I completely understand that, if you're that a lot of people feel more comfortable with the numbers. Okay, so the next step is we look at the y equation. I'm just going to copy this equation. Okay, and now I'm going to substitute this expression into this equation. And so I end up with T1 sine theta 1 plus, okay, so now I need T2. So T2 is this expression. So it's T1 cos theta 1 over cos theta 2 sine theta 2 minus W equals 0. Okay. And so I want to bring the W over to that side of the equation. And I want to factor T1 out of this piece. So end up with T1 sine theta 1 plus cos theta 1 sine theta 2 over cos theta 2 equals W. We're solving for T1. I get T1 equals W over sine theta 1 plus cos theta 1 sine theta 2 over cos theta 2. And that's your answer. If we were doing this with numbers, I just have to substitute numbers into this expression. So I get T1 times sine of 60 degrees. And it turns out that sine of 60 degrees is 0.866. Okay. And then I have the next term. All right, so the next term is just this T2, which is 0.52 T1, and then sine theta 2. So I have 0.522. Was that the number? Yeah, I guess 0.52 is what I had. 52 T1. So this thing here. T2. All right. And then I want to multiply that by sine theta 2. Right? And theta 2 is 15 degrees. Sine of 15 degrees is 0.259. I might as well annotate this as well. So here was sine. All right. And then I have minus W, and W is 3,000 newtons. Okay. I now multiply this out. So T1 times 0.866 plus 0.52 times 0.29 minus 3,000 newtons equals 0. And it turns out that if you take out your calculator and do this, this is 1. All right. That's because the numbers were chosen to be nice. That generically, if I chose 25 degrees instead of 15 degrees, this would be like 1.1 or something like that. So there's no magic that's making this one. It's just you given nice numbers here. And so the end we get T1 equals 3,000 newtons. Okay. So the textbook chapter has several examples of doing this. You'll be doing more problems like this on the homework. The challenge here is being systematic and keeping the trig function straight. And it's something that everyone can develop mastery of. You don't need some intrinsic physics intuition or something. This is just being systematic.